Hello class, today what we are going to do is we're going to look at proving triangles congruent. Now in the last two videos we looked at some theorems that we could use to prove triangles congruent. The side-side-side theorem, the angle-side angle, side-angle-side, all of those things. All right. And then we looked at when we can use which ones, how they're applied. Today we're going to do some actual proofs in this one. So here we go. Let's take a look at, let's zoom in a little bit so we can see. Okay. Move it down underneath my face. There we go. So we are given that segment JN is congruent to segment MN. We are given that segment NK is congruent to segment NL. We want to prove that triangle JNK is congruent to triangle MNL. So we're looking at these two triangles here. Now, we said before that we have to have 3 sets of congruent parts, right? And they had to be specific ones, though. So let's take a look. And first things first, let's go ahead and write down our givens. Always got to start with that. So we see statement number 1, segment JN is congruent to segment MN. Also, segment NK is congruent to segment NL. So we are given this. So that's what we were given. Go ahead and get that down. Draw a line there to keep our rows separate. Now, that's 2. We said before we have to have 3 things, 3 congruent parts shown. 3 corresponding parts congruent. There we go. 3 corresponding parts congruent in order to show congruent triangles. We've got 2. We have to get a third thing. We either have to get a side or we have to get an angle. Now, looking at this, our third side over here, JK and ML, I have no information about. I don't know. They might be, they might not be. We have nothing there. So we can't use sides. Okay, so what about angles? Well, if you notice, we do have a vertical angle right here. And so since those are vertical angles, that means those are congruent. So we need to put that. So, okay, so number 2, we can say that angle JNK, that's a 2, it's terrible. Anyways, angle JNK is congruent to angle MNL. Why? Because they are vertical angles, and this is the vertical angle theorem, vertical angle congruence theorem. So let's see, number 2. This is the vertical angles congruence theorem. Congruence theorem, T-H-M. Okay, so now I have a side, I have an angle, and I have another side. Okay, so I've got the angle in between the 2 sides. We've got to check and make sure that's one of those that works, because remember, there was some that didn't. So let's see here. We had 2 sides. So this is 2 sides, that's 2 sides. We have this angle in between the 2 sides, so side, angle, side. And that is one of them that works. SAS is a good one. So that works. So since we have a side, an angle, and then another side, we can say that these triangles are congruent. So, final statement here, triangle JNK is congruent to triangle MNL. Why? This is because of the side, angle, side congruence. Congruence. And you do need to say that this is the side angle side congruence theorem, not just SAS, because there are some other things that we can do with this. There are other theorems, so you got to specify that this is the congruence theorem, not some other theorem. Alright. So there we go. That one wasn't too bad. It was pretty short, pretty sweet. Not a big deal. Okay, so let's take a look at the next one. Here we are given a lot of congruent segments, and we need to prove triangle EFG. Let's see which one is that. EFG, so that's this big triangle here, is congruent to triangle HIJ. So HIJ, so that big triangle there. Alright, so let's take a look at this. First, we have to write down a given. We've got a great big given. We've got to write it down. Okay, so we have segment IE congruent to segment EJ, congruent to segment JL, congruent to segment LH, congruent to segment HK, congruent to segment KI, congruent to segment EK, congruent to segment KF, which is congruent to segment FH, which is congruent to segment HG, which is congruent to segment GL, which is congruent to segment LE. That's a lot of stuff congruent to each other. And we know all this because we were given this information. Given. And let's draw a line on it so I don't get blended in with that one. So now, we have this great big triangle there. And we have this big triangle here. So, what can we do? Our options are to get three sides congruent, or our options are to get one side and two angles, or two angles and two sides and one angle, something like that. So we take a look here on these two triangles, the two big ones. Do I have any information about the angles? No, I don't have any information about the angles, which means all we're left with is the sides. So we need to get all three sides, all three pairs of corresponding sides congruent to each other. All right. So let's see here. What can we do with this? Well, I don't really have EF. It hasn't said anything in here about segment EF or EG or IJ, but we can take these two segments and these two segments, we could add them up. So IE plus segment EJ, the lengths of those would equal the length of segment IJ, right? That's segment addition. So we could add those up. And that would get us something to do with the sides of these two larger triangles. We could add up the lengths of the sides. All right. And we know that all these segments are congruent, which means they have the same length. And this is an annoying step to put down because it's really, pretty obvious, but we do have to put it down. So first, what I'm going to do is I'm going to take this and I'm going to change all of these from being segments congruent to each other to segments that have the same length as each other, because that's what it means. All right, so the length of IE, no segment above it, equals the length of EJ, which equals the length of JL, which equals the length of LH, which equals the length of HK, which equals the length of KI, which equals the length of EK, which equals the length of KF, which equals the length of FH, which equals the length of HG, which equals the length of GL, which equals the length of LE. All right. How do I know this is true? I know this is true because they're congruent to each other. Right? That's the definition of congruent segments. So, definition of congruent segments. Congruent segments. All right. So now that I'm looking at the lengths of the sides, I can add those lengths together, okay? And that way I can have something having to do with the lengths of these sides here. So I'm just going to add a bunch of these segments together to get the lengths of the sides that I want, okay? The sides of the big triangles. So let's see here. Let's start up here. We have segment IJ, so that would be IE plus EJ. So the length of IE plus the length of EJ equals the length of IJ. Okay, let's go JH. That would be JL plus LH. So the length of JL plus the length of LH equals the length of JH. And with that one, HI, so that would be HK plus KI equals the length of HI. Okay, so that's the first triangle. Now let's do the other triangle. We'll start with FE. So that would be the length of FK plus the length of KE equals the length of FE. And then we need EG. We'll just go around this way. So that would be EL plus LG equals the length of EG. And then finally we have FG, so that would be GH plus FH equals the length of FG. Alright, so that is all of the sides of my two large triangles, and I did all of this with segment addition. So segment addition, T-I-O-N, I cannot spell. Segment addition postulate. Okay. So what can I do with that? Well, let's see here. I know that all of these segments that I just added up are equal to each other. They all have the same length. And if they all have the same length, that means I can use one in place of the other. I can substitute them all in. So what I am going to do is I'm just going to take all of these and I'm just going to substitute IE for everything, because everything here equals the length of IE. So I'm going to substitute IE for all of it. So number 4, I'm going to change all of this to say IE plus IE equals IJ. I'm going to say IE plus IE equals JH. IE plus IE equals, what was that, HI. Let's see here, we have IE plus IE equals FE. IE plus IE equals, what was that, EG. And IE plus IE equals FG. And it doesn't matter. I could have substituted everything in for something else. I could have called it HG plus HG. It would have been fine. Nobody cares. Because they all equal each other, so they're all the same thing. All right. All right, and this is the substitution property. It would really help if I could spell it. Substitution property. Okay, so now I have all of these sides are equal to the same thing, right? They all equal IE plus IE, every single one of them. And as we've said before, as we know, if two things are congruent to the same thing, or if two things equal the same thing, they're equal to each other. This is transitive property. So, step 5, I'm going to say they all equal each other. IJ is the same length as JH, which is the same length as HI, which is the same length as FE, which is the same length as EG, which is the same length as FG. Why? Transitive property. They are all equal to the same thing. So, transitive property. Okay. Now, if they all have the same length, that means they're all congruent. And I really have to say that they're congruent. I can't just say that they have the same length. So I am running out of room. This took longer than I expected. So segment IJ is congruent to segment JH, which is congruent to segment HI, which is congruent to segment FE, which is congruent to segment EG, which is congruent to segment FG. How do I know that? Because they all have the same length, and that's definition of congruent segments. So I'm going to abbreviate here. Definition of congruent segments. Okay, so now let's take a look at our triangles again. We have said that all three sides of this triangle are congruent to all three sides of that triangle. And that means we can use side, side, side. All right, that's one of our theorems. Side, 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 congruence theorem. Alright, so last step, which I just barely have room for, triangle EFG is congruent to triangle HIJ because of side, side, side congruence. Congruence theorem, and I'm running out of room again. Alright, so we'll read that. Side, side, side congruence theorem. So it took a little bit longer. It wasn't all that difficult. It was just a lot to write. Okay, showing everything's congruent to everything else. So there it goes. That one was a little bit more work. Let's take a look at these other ones. Got two more. All right, so let's see. On this next one, we are given that segment AC bisects angle DAB, and it also bisects angle DCB. Alright, so it's going to bisect this angle, it's bisecting, looks like this reflex angle here. And we want to prove triangle ABC is congruent to triangle ADC. So first thing first, write down the given. And then after we get that down, then we'll look at figuring out what we're going to do with this. So segment AC bisects angle DAB and angle DCB. We know this because it was given to us. Alright. So now, we're trying to prove two triangles congruent, which means we need to get three corresponding parts congruent. So sides, angles, something there. Let's see here. So I always like to look for side, side, side first because it's the easiest one. And I've got these two sides with no information about them, but I do have segment AC that's in both triangles, right? And if it's the same segment in both triangles, that's going to be congruent. So that's one side, but I can't get the other side. So what can I do if I only have one side? Well, I need to get two angles. So what can I do to get that? Well, let's see. First, let's go ahead and write down that segment AC is congruent to segment AC, because that's nice. Segment AC is congruent to segment AC, and if you will recall, I don't know why I can't write a 2 today, this is the reflexive property. Reflexive property. Technically reflexive property of segment congruence, but reflexive property is good enough. Most teachers are going to be fine just putting reflexive property. So that'll be fine. Okay, now we've got one segment congruent, we have one side, we need to get some angles. And I don't really have much in the picture, so let's go back to our given. We are given that segment AC is bisecting both of these angles. But what does it mean if you bisect an angle? That's right, it means that it cuts it into two congruent angles, right? So what that means is that these two angles are congruent and that these two angles are congruent. That gives us our other two congruent angles, doesn't it? So that gives us our three parts. So that'll work. So here we go. Let's write down that these angles are congruent. So first we have angle BAC. So angle BAC is congruent to angle DAC. Things up off the screen, that's no good. To angle DAC. And also angle BCA is congruent to angle DCA. So angle BCA is congruent to angle DCA. Why? Because AC bisects it. This is the definition of a bisector. Definition of, when you specify this is an angle bisector, not a segment bisector. So definition of angle bisector. Definition. Alright, so now I have one side and two angles congruent. So I did have two different theorems that had two angles in one side. So the question, is this going to be angle side angle or angle angle side? Because they're different. Let's see, which one do we have? Well, let's see, we have this angle, and then we have the side that connects them. So the side that's in between those two angles, so that's going to be angle angle side. So we have step 4, we're going to say that the triangles are congruent. So triangle ABC is congruent to triangle ADC. Why? This is the angle side angle congruence theorem. 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 And there it is. So that one wasn't too bad. That was a lot shorter than the previous one we did. Okay. So again, make sure we're looking for three things congruent. That's what we're trying to do. Figure out what we can get congruent to each other. So we got one last one down here. Alright, and they didn't give me the little T-chart. That's okay. I'll just make my own. There we go. And we have statements. And we have reasons. Okay, so what are we given? We are given that segment BD bisects segment AE. We are given that angle A is congruent to angle E. I'm going to go ahead and write that down, and then I'll start planning stuff out. So BD bisects segment AE. Angle A is congruent to angle E. I know this because it was given to me. Given. So I need three congruent things, right? So far I have one. Okay. What else can I get just by looking at the picture? I can get an angle. Right there. I got vertical angles just like we had on the previous one. So we've got vertical angles right there. So that gives me another thing that's congruent. So that'll work. I can go ahead and put that down. So number 2, let's do that. So number 2, we can say we've got vertical angles. So angle, what is that? ACB is congruent to ACB. Those correspond, so that'll be ECD. To angle ECD. Why? Because these are vertical angles. So vertical angle congruence theorem. Yes, I abbreviated it a lot because I can't spell. So I now have these two angles congruent. I need one other thing congruent. Well, what can I do? Well, I don't see anything else in the picture, so let's go back to the given. See, we've already got that. Oh, bisect. We haven't done anything with this bisecting. So segment BD bisects segment AE. So what does that mean? Well, what that means is that AC is congruent to CE. It cuts it in half, perfectly in half. Now, real quick, does that mean that BC is congruent to CD? No, it does not. Because it does not say that AC is bisecting BD, it just says that BD bisects AE. So this one is being cut in half. This segment BD, not necessarily. Okay, so really all we know is these two are congruent. So let's go ahead and write that down. That's probably going to be helpful since they gave it to us. So we can say that segment AC is congruent to segment CE, and we know this because definition of a segment bisector. All right? So definition of segment bisector. Do you need to specify this is a segment bisector, it's not an angle bisector? Segment bisector. Okay. So let's see, what do we have? We have one angle congruent, we have two angles congruent. Oh, two angles on a side, good. So let's see here, we have these two angles, and it was this side here. So, all right, we've got angle, side, and an angle again. Angle, side, angle. So this is the same thing we had in the last one. All right. So that is three that work. So that works. We can say our triangles are congruent. triangle ABC is congruent to triangle EDC. Why? Because of ASA congruence. Theorem. And there it is. So, hopefully you found that useful. We've done 4 proofs here, so we can look at this 4 different ways, different things we can look for when we're doing proofs. Most of them fairly short, not too bad. We did have this one, which, while it wasn't terrible, it was kind of long and a bit drawn out. So, anyways, hopefully you found that useful, and I will see you next time.